Hello, what's up guys? Welcome back to your JavaScript series brought to you by Coach CTC. In case you skipped the previous episode and bumped into this one, I'll still remain Tony Cletus, your instructor. Alright, so in this episode 29, we're going to be looking at two other great patterns of creating objects in JavaScript. So these two great patterns is going to help us to achieve this object-oriented programming concept in this case. And we'll use them to solve problems. The same problem we're going to be solving is the one we've been solving earlier, which is company with employees, just like a salary management systems that we have been doing. So before me here, we have what we've done in the previous episode, where we try to create an object using the popular method, which is called the constructor pattern, or using the constructor function. In Java we also do it this way. It's just that in Java you have to use a class, so we call that method class-based inheritance. But JavaScript is using a constructor function, not a class this time, so we call that method prototypical inheritance. What we'll try to do now is we'll try to create an object using the prototype pattern, and then we try to twat it to a dynamic prototype pattern. So that's what we'll cover in this episode. You might be asking, why would I need to learn another pattern again if we can achieve object-oriented programming concept with the constructor function? But I'm telling you that the constructor function is still having some problems, you understand? There are some loopholes here. When we actually created an object, you understand, that inherited from this employee constructor function here, we discovered that it will just inherit everything, all the properties and all the methods. That's one thing. When you create another object, even though the object is not using this method, for instance, it will still inherit all this stuff, you understand? For instance, in the last episode, Jane is using two methods here, this method and this method, and John is just calling the getTotal method, you understand? So that is very bad. So what the prototype pattern will help us to do here is to enable us to create a lightweight object, you understand? A lightweight object that will just use the specific properties and methods that is needed to be used, you understand? So first of all, we still use a normal function. We will still create a function, and this time around we'll just name it something like employee proto. Then you are going to create an empty object, you understand? In this case, we're not going to put our properties and our method inside this object again. We'll do that at the prototype space, you understand? So that if we inherit this particular constructor function or this particular class, let me just use class for example, we won't need to inherit everything inside again, but just the one that we need for each object. So that's an empty object there, and we'll create our prototype space. What we'll do, we'll declare our properties and our method, the prototype space. So the first thing is we'll try to use the name employee proto dot the name of the property, understand, and we initialize everything. So it will set it to default, you understand? So for now the default is no name, and we come down here and say employee.proto. Remember in our last tutorial we have just three properties: name, salary, and bonus. So salary is equal to, and just set it to default 0, and the last one, the last but not the least, prototype.bonus is equal to 0 also. So we've initialized our three prototype properties. So what we'll do next is to define our method that will just compute or sum salary and bonus together, understand? So we'll do employee.prototype.getTotalPay, and we'll open this curly braces, and here we'll do this. Now here you are going to use the this operator again. So it's a this.salary plus this.bonus. So actually what I'll do is I'll have a parameter in the method total pay, so that we'll just let it hold the solution from here as always. So total pay is equal to this dot salary plus this dot bonus, you understand? And then we come down here to output the solution on the screen. I have some string, the total Alright, so the total pay for this dot name plus concatenating this with is total pay. So what we'll just do now is to create the objects. Just like we did in the constructor function, we'll try to declare a variable and let it inherit these properties and method, including the one in this prototype space. This is our prototype space and this is our empty object. So we'll try to do that, and we say var staff1 is equal to new employee proto. These now are default values. We'll assign value to the staff1 object. So say staff1 dot name is equal to John Hart, and then staff1 dot salary is equal to, let's use 5,000 again. Then staff1 dot bonus is equal to 500.5, and then we call our method, the name of our method, get total pay, and that's all. So if we save this now and we try to output, I think there's an error somewhere. So we didn't finish this function. So say employee proto dot prototype dot get total pay is equal to, it's equal to a function, and you didn't correct me. All right, you can't do that anyway, and this is a parameter. So if we save this now and we open our web browser, we refresh, we should have total pay for John Holt is $5,500.5. And you see, we've tried to solve this our problem using the prototype pattern. The prototype pattern really makes us to create a lightweight object. By that I mean we have a function that we've inherited from, but remember this constructor function has no property and no method defined inside. Rather, it is defined outside of this constructor function as a prototype space. So it's just outside. We just need to pick any property that we want to use. So even though I create another object, for example, we have staff2 and it's inheriting from the employee proto also, we discover that it's just taking the necessary thing that it requires, not everything, you understand. So if you save this and we refresh, okay, hopefully I should have a list tag here. So if we save this and we refresh here, we should have the same thing, you understand. So now I won't create a loan method again like we did in the last episode, where we have to deduct the amount loaned from this company, but you get the idea of what I'm trying to do. So you can still create multiple methods inside this prototype space and test it out, you understand. You can only call it for each of the objects. So if I clear this, let's do something interesting here now. If I comment on this particular property, by that I mean this object explicitly has no property called name now. So if I come back to our web browser and I refresh, you see that it does not acquire the default value no name on the prototype space. Now let's do something again. We'll check if name exists in staff1, and I open my console, refresh. You see it's giving me the value true. That means the name property actually exists in the program here. Why did I say the program and not the object? Now what will happen is it will check for this name property inside the object. If it doesn't see it inside the object, it will go ahead and search for it inside the prototype space, and once it gets hold of the property name, it will give us the value true. And that's why you're seeing the value true here. But if we want to specifically check if the name property is available in the object, we can also do that to confirm. So if I do console.log staff1 has own property parenthesis and type the name of the property we're trying to look for. So if I save this now and we come back to the console and refresh, sorry, let me clear this up, and I refresh, you see that we are getting the result false. You understand? The name property is not used or defined inside the object here because it has been commented. So if I uncomment this and we come back to our console, we refresh. Let me clear this. It is now giving us the value true. That means it has gone ahead and searched for this name operator and has seen it that it has been defined explicitly inside the object. You understand? So that is it. I don't have any other way to explain this for you again, but I believe you understand what I'm trying to convey here. So that's all about prototype pattern, but there's still a problem about this prototype pattern, and that's why we're going to the dynamic prototype pattern now. And the problem is that if we try to create these objects and the properties, we explicitly define them on different lines. You can't just write them on one line like we did in the constructor function, where we have all our values assigned to our properties on a single line inside the parentheses. So we can't do that here. It's taking time, and we programmers will try to write the simplest amount of code, a more efficient code, little code that performs great things. You understand? We should look for a way to make it simple. And another thing again is, if you have multiple objects, it will get you confused because you will be defining your properties and your method on different lines over and over again to get you confused. So let's try to convert this particular example to a prototype pattern. So what I'll do now is to copy this, then Ctrl+Shift// to comment this, and I'll come down here and paste this one here. So we'll try to change this one to dynamic prototype pattern. So here I'll change this to dynamic. In this case, we'll just do it like the constructor function. We'll have our properties and our method inside the class or the constructor function. So I have it as name. This is the salary. So if I have this now, I'll have to clear this one off, and what we'll do next is we'll have our method, right? But there's how we're going to do this method, you understand? So what we'll do is, let's go this way. Please don't be confused. I'll say if this dot get total pay is not equal to the name function, then we want to create a function. So what we're trying to do here is, if this method is not a function, if the first object we're going to create doesn't have the method with the name get function, it will create this method for us, you understand? And this method is a prototype type, you understand? The next object that is going to run this will not need to create another function again. So the first object will check if this dot get total pay, this method, is a function or is inside our program and is a function. If it's not inside, it will create this method for us. Let me comment this. I'll just copy this one and paste it here, like we've also inherited from this constructor function. Let me still call it constructor function, this function here. So we'll be able to define, we'll see we've solved the problem to define all our values here. Here now I'll have as the parameters name, salary, and bonus. So here now we have their values defined here. So we have Jane and salary 4,000. Oh, sorry, this is an integer, and a bonus 4.50. All right, so and then we call the method for staff one, rather, get total pay. We save this and let's test it and see how it goes. So if we refresh this, oh, I'm getting an error. Oh, actually it's telling me employee is not defined. Oh, sorry, I was supposed to change this to employee dynamic. We're not dealing with prototype again, so I'll just change that to employee dynamic. So if we save this and we open a web browser, we refresh, hopefully we should have the total pay for Jane is 4,400.5. and here you see that it's very simple. Now we can also do this for John, and John will be staff 2, and we save, come back here, refresh. You see, we now have a very clean and efficient code. I guess this is the last part that I'm going to be teaching you in terms of creating objects. So this is object-oriented programming, my friend. This is object-oriented programming concept. And in this prototype pattern, I'm telling you that we've created a lightweight object. We've made this code very efficient and really usable and very simple to understand. Alright, so I believe there's nothing more to explain here. In our next episode, we will try to look at examples of some standard built-in objects. In our previous episode, I guess it should be the introductory aspect, we said object is divided into the standard built-in object and the custom built-in object. So we've been dealing with the custom way of creating objects. Thank you guys for watching this video. If you really learned something from this episode, you can click on that like button below and don't forget to subscribe.